Download this code from codegive.com, link in the description below. Archicad GDL script execution order, a deep dive with examples. The graphics description language, GDL, in Archicad is a powerful tool for creating parametric objects. Understanding the order in which GDL scripts are executed is crucial for writing efficient and predictable code. This tutorial provides a detailed explanation of the execution order, complete with code examples to illustrate key concepts. The different script types and their purpose. Before diving into the execution order, let's define the primary GDL script types and their purposes. Parameters script *. This is the first script to run. It's responsible for defining the parameters of your object. Parameters are variables that allow users to control the object's geometry and properties. Here you define the name, data type, range, default values, and UI behavior of each parameter. Think of it as the blueprint for your object's customization. Property script *. This script calculates and assigns values to properties. Properties are read-only attributes that describe the object, often derived from parameter values or other calculations. Examples include surface area, volume, or a custom classification code. These values are displayed in schedules and reports, providing valuable information about your object. Values script *. This script calculates complex formulas or lookups based on parameters. It is often used to define complex relationships between parameters, or to retrieve values from external tables or data sets. These derived values can then be used to control the object's geometry or other properties. It's often used in objects where direct manipulation of parameters might not give the desired results, and complex formulas define the behavior. 2D script *. This script draws the object's symbol in 2D views, plan, elevation, section. It uses lines, arcs, fills, and other 2D primitives to create the graphical representation. 3D script *. This script draws the object's representation in 3D views. It uses commands to define geometric shapes, prism, block, cone, etc., and apply materials and textures. Migration script *. This script is automatically executed when an object from an older Archicad version is placed in a newer version. It's used to update the object's parameters and geometry to maintain compatibility. This is less frequently used, but critical when maintaining legacy objects. Interface script *. This script defines the custom user interface for your object. It allows you to create custom dialog boxes with specific controls and layout, enhancing the user experience for complex objects with many parameters. 2. The order of execution. The execution order of GDL scripts is crucial for understanding how Archicad processes the object definition. Here's the breakdown. 1. Parameters script *. This is always the first script to execute. Purpose, define parameters and their attributes. Key actions. Declare parameters using the parameter statement. Assign default values. Set parameter attributes, range, increments, options. Define UI behavior, visibility, editable status. 2. Values script. Once this runs once when the object is first loaded, after the parameters script. Purpose, perform initial calculations or data lookups that only need to be done once. Key actions. Initialize global variables or arrays. Read data from external files, if applicable. Calculate values that will be used later in other scripts. 3. Property script *. This script runs before the 2D and 3D scripts. It is executed after a change to the parameter values. Asterisk purpose, calculate and assign values to object properties. Asterisk key actions. Asterisk calculate area, volume, or other physical properties based on parameters. Asterisk assign classification codes or other descriptive attributes. Asterisk use formulas and functions to derive property values. For 2D script asterisk executed before the 3D script, only when a 2D view is active, plan, section, elevation, detail. Asterisk purpose, generate the 2D symbol of the object. Asterisk key actions. Asterisk draw lines, arcs, fills, and other 2D primitives. Asterisk use parameters and calculated values to control the symbol's appearance. Asterisk handle different level of detail, LOD, representations. 5 values script, before 3D. This runs before the 3D script, only when a 3D view is active or 3D model is rebuilt. Asterisk purpose, perform pre-processing necessary to create a correct 3D model. Asterisk key actions. Asterisk calculate values that affect the 3D model shape. Asterisk check for invalid parameter combinations and adjust values if needed. 6 3D script asterisk executed after the values script, before 3D, only when a 3D view is active or the 3D model is rebuilt. Asterisk purpose, generate the 3D model of the object. Asterisk key actions. Asterisk define 3D geometric shapes, prism, block, cone, sphere, etc. Asterisk apply materials and textures. Asterisk control the object's visibility and level of detail, LOD. 7 values script, before hatch. This runs before the 2D hatch script, if any, after 3D or 2D script. Asterisk purpose, calculate or update values that will be used for the hatch definition. Asterisk key actions. Asterisk recalculate hatch pattern parameters based on parameter changes. Asterisk prepare data for generating custom hatch patterns. A 2D hatch script, optional, executed after 2D or 3D script if defined. Asterisk purpose, define custom hatches for fills and surfaces. Asterisk key actions. Asterisk define lines, dots, and shapes to create custom hatch patterns. Asterisk use mathematical formulas to define the pattern. 9 interface script, on demand. This script is only executed when the object's settings dialog is opened and the interface is rebuilt. Asterisk purpose, define a custom user interface for the object. Asterisk key actions. Asterisk define dialog boxes, controls, and layout. Asterisk handle user input and update parameter values. 10 migration script, automatic. This runs automatically when an object is migrated from an older Archicad version. Asterisk purpose, update the object to be compatible with the newer Archicad version. Asterisk key actions. Asterisk update parameter values. Asterisk adjust geometry. Asterisk add new features. Important considerations. Asterisk triggers. The property, values, 2D and 3D scripts are re-executed whenever a relevant parameter is changed. This is how the object updates its representation in response to user input. Optimization. Minimize the number of calculations in the 2D and 3D scripts, as they are executed more frequently. Use the values script to pre-calculate values that can be reused in the drawing scripts. Error handling. Use the if statement and other control structures to handle potential errors, example division by 0, invalid parameter values. This can prevent your object from crashing and improve its reliability. 3. Code examples. Here are some code examples to illustrate the execution order and how different scripts interact. Example, simple desk object. This example defines a simple desk with adjustable length, width, and height. 1. Parameters script ***. Explanation ***. Parameter, this keyword indicates the start of a parameter definition. Length equals 120, this defines a parameter named length with a default value of 120 units. Length, this is the user-friendly name that will appear in the settings dialog. Length, this specifies the data type of the parameter, length in this case, which typically means meters, feet, or millimeters depending on the project settings. The script defines similar parameters for width and height. 2. Property script ***. Explanation ***. Properties, this keyword indicates the start of the property definition. Area equals length **width, this calculates the surface area based on the length and width parameters. We divide by 10,000 to convert mm2 into m2. Surface area, this is the user-friendly name for the property. Area, this specifies the data type of the property, area. The script similarly calculates the volume. 3. Values script, once. Explanation ***. This script initializes a global variable desk_color with a default value. This value will be used in the 3D script. Global variables retain their values between script executions, within the same object instance. 4. 3D script ***. Explanation ***. Material desk_color, this sets the material of the desk to the color defined in the values script. Block length, width, height, this creates a rectangular block with the dimensions specified by the length, width, and height parameters. 5. 2D script ***. Explanation ***. pen1, sets pen to a specific color. Rect 0,0 length, width, this draws a rectangle representing the desk in plan view. The rectangle's dimensions are controlled by the length and width parameters. pen9, sets pen to another specific color. Hotspot, defines hotspots. These spots are clickable points in the 2D view, used for snapping and editing. How it works together *1. When the object is placed, the parameters script is executed, defining the length, width, and height parameters with their default values, 120, 60, 75. 2. Then the values script, once, is run, setting the desk color to index 3. 3. Archicad then checks if the property script needs to execute. In this case, since it's a new placement, it does. This script calculates the area and volume based on the parameters and assigns them to properties. 4. If you are in a 2D view, example floor plan, the 2D script is executed. It draws a rectangle representing the desk, using the current values of the length and width parameters. Hotspots are created for easier object interaction. 5. If you are in a 3D view, the values script, before 3D, runs. In our example, this doesn't change anything, as desk_color is already set by the values script, once. 6. Finally, if you are in a 3D view, the 3D script is executed. It creates a 3D block representing the desk, using the length, width, and height parameters, and assigns the predefined desk_color to it. If you change any of the parameters, example change the length to 150, the following happens. 1. The parameters script is not re-executed, parameters are already defined. 2. The property script is re-executed. The area and volume properties are updated based on the new parameter values. 3. The 2D and 3D scripts are re-executed, depending on the active view, reflecting the updated dimensions of the desk. The values scripts are run again before each of the 2D and 3D scripts if their respective view is active. 4. Advanced example, window with customizable frame and glazing. This example demonstrates a more complex scenario with dependencies between parameters, requiring the use of the values script. 1. Parameters script ***. 2. Values script, once. 3. Values script, before 3D. Explanation of the values script, before 3D. Current _glazing _material equals glazing _materials glazing _type, retrieves the correct material from the global material array based on which glazing type is chosen. If ABS, width, frame _width *2, 1 then. And if, the code adjusts values if the width/height of the window is very close to 2 times the frame width. This helps to avoid geometry issues where the frame would appear to be too wide. It prevents a potential invalid scenario. 4. 3D script ***. Explanation of 3D script ***. ***addz frame _depth, this moves the coordinate system up by the frame depth. *block width, height, frame _depth, creates a block representing the frame. *del frame _depth, moves the coordinate system down by the frame depth. Material current _glazing _material, sets the material for the glazing based on the value calculated in the values script. The ADDX, ADDI, and ADDZ commands shift the origin to position the glazing correctly within the frame. Block width, 2 frame _width, height, 2 frame _width, 1 creates a thin block for the glazing. Del removes transformations applied by the add statements, resetting the coordinate system. Explanation of key concepts global variables the glazing _materials array and current _glazing _material are declared as global. This means their values are preserved between script executions. This allows the values script to initialize these settings and for the 3D script to access them. Conditional logic ** the if statement in the values script is used for input validation and setting limits. Coordinate system manipulation * the ADDX, ADDI, ADDZ, DEL, DELX, DELI, and DELZ commands are used to manipulate the coordinate system, allowing you to easily position different parts of the object. Material assignment * the material command assigns a material, color index, to the object. This allows you to control the appearance of the object. Best practices. Plan ahead * before you start writing GDL code, plan the object's structure, parameters, and relationships. This will help you avoid unnecessary complexity. Use comments * add comments to your code to explain what each section does. This will make it easier for you and others to understand and maintain the code. Break down complex tasks * divide complex tasks into smaller, more manageable functions or procedures. This will make the code easier to read and debug. Optimize for performance * minimize the number of calculations in the 2D and 3D scripts, as they are executed more frequently. Use the values script to pre-calculate values that can be reused in the drawing scripts. Error handling * use the if statement and other control structures to handle potential errors, example division by 0, Invalid parameter values. Test thoroughly. Test your object thoroughly with different parameter combinations to ensure that it behaves as expected. Use version control. Use a version control system, example Git, to track changes to your GDL code. This will make it easier to revert to previous versions if necessary. 6. Debugging GDL scripts. Archicad provides some limited debugging capabilities. Alerts. Use the alert command to display the values of variables or expressions during script execution. This can help you identify problems with your calculations. Output window. Check the output window in Archicad for error messages. This window will display syntax errors and other problems that occur during script execution. Interactive parameter changes. Experiment with changing parameter values in the object's settings dialog to see how the object responds. This can help you identify problems with the interaction between parameters and the drawing scripts. Breakpoints. Limited. While not a true debugger, you can use a series of alert statements to simulate breakpoints, stepping through your code section by section. 7. Conclusion. Understanding the order of GDL script execution is essential for creating parametric objects in Archicad. By understanding the purpose of each script type and how they interact, you can write efficient, predictable, and maintainable code. This tutorial has provided a detailed explanation of the execution order, along with practical examples and best practices to help you get started. By using this knowledge, you can create powerful and customized objects that meet your specific needs. Remember to plan ahead, use comments, optimize for performance, and test your objects thoroughly to ensure their reliability. Good luck.